Sound lesson number 14. We hear various voices in our daily life. We hear people speaking, children laughing and crying by hearing the bell ringing. Students come to know that it is time for prayers. When you hear the doorbell, you come to know that someone is at the door. We hear sounds of buses, cars, vehicles, etc. moving on the roads. We hear chirping of birds, croaking of frogs, moaning of cows, etc. These voices are called sound. Thus, sound is a form of energy which causes a sensation of hearing in human ears. Sound is very important in our lives. It helps us to communicate with one another. We hear a variety of sounds around us. Flute is played by blowing up. How are other instruments played? How are all these sounds produced? How does a sound travel from one place to another? How do we hear sound? Why are there various kinds of sound? We shall try to find answers to such questions. Sound is produced by the vibrating bodies. When you ring a cycle bell and then touch it gently, you feel vibrations in the bell and hear its sound. Touch the bell when it is not ringing. You do not feel the vibrations now and you do not hear any sound. This makes clear that sound is produced by vibrations. Activity 1. Take a brass tumbler and a pencil. Place the tumbler and gently strike the edge of the tumbler with the pencil. Sound is produced when you strike the edge of the tumbler. Now touch the edge of the tumbler with your hand. You feel the vibrations clearly, but the sound stops when you touch it. You will not feel the vibrations when you touch the tumbler after it stops producing sound. This is shown in figure 14.2. Activity 2. Stretch a rubber band around a pencil box as shown in figure 14.3. Insert two pencils between the box and the stretched rubber. Now pluck the rubber band from the center. Do you hear any sound? Does the rubber band vibrate? Activity 3. Take a metal pan, put it on a table in such a way that it does not touch any wall. Now strike it with a pencil, touch the pan gently with your finger. Do you feel the vibrations? Again strike the pan with the pencil and hold the pan tightly with your hands immediately after sticking. Do you still hear the sound? Touch the pan when it stops producing the sound. Do you feel the vibrations now? You know that to and fro or back and forth motion of an object is called vibration. When a tightly stretched rubber band is plucked from the middle, it vibrates and produces sound. When it stops vibrating, it does not produce any sound. So you see that vibrating objects produce sound in some conditions. These vibrations are easily visual to us, but in most but in most cases their amplitude is so small that we cannot see them, but we can feel them. Activity 4. Take a clay bowl and make a katra with it. Play the egg katra and identify its vibrating part. Make a list of a few musical instruments and identify their vibrating parts. Some examples are given in table 14.1. Complete the rest of the table. You must be familiar with manjira, cymbals, ghatam, claypot, and the kartal. These musical instruments are used in many parts of our country. These instruments are simply beaten to produce sound. Have you seen a few other such instruments? You also can make a musical instrument. Activity 5. Take 5 6 glass tumblers, fill them with water gradually increasing from one end to the other. This is shown in figure 14.7. Now strike the tumbler gently with a rod one by one. You will hear You will hear pleasant sound these musical instruments in Jaltrang. When you pluck the string of a sitar, you not only hear the sound of the string, you hear the sound of the vibration of the whole instrument. Similarly, when you strike the membrane of a dholak, you not only hear the sound of the membrane but of the whole body of the instrument. Sound produced. Sound produced by humans. Speak loudly for a while or sing a song or hum. Touch your fingers on your throat. Do you feel vibrations? Sound is produced by larynx in humans. Touch the throat. Find a hard bump that seems to move when you slow. It is at the upper end of the windpipe. It is called the voice box or the larynx. There are two stretched membranes called the vocal cords. These vocal cords are stretched in such a way that it leaves a narrow slit between them for the passage of air. When the lungs force air through this slit, the vocal cords vibrate. Vocal cords produce different sounds when these are stretched and when these are loose. Activity 6. Take two rubber strips of the same size. Keep these two strips one above the other and stretch them tight. Now blow air through the gap between them. It's a sound produced when you blow air through the rubber strips. Do your vocal cords produce sound in a similar manner? This activity is shown in figure 14.9. Vocal cords, each main, are about 20 mm long and the length of the vocal cords is woven is about 15 mm. Vocal cords in children are very small. This is the reason why the voice of men, women, and children are different. Sound needs a medium for propagation. When you call up your friend who is standing at a distance, your friend is able to hear your voice. How does your sound reach him? Activity 7. Take a plastic bottle, cut the lower part of the bottle and remove it. Now place a mobile on a board and cover with the upper part of the bottle. Apply wax between the board and the open end of the bottle so that air does not enter inside. Ask your friend to call on this mobile using another mobile. You will hear the ring clearly. Now fix a cork with the drain pipe on the mouth of the bottle. Remove the air from inside the bottle using a suction pump. Through the drain pipe, you will find that the sound of the ring gradually decreases. When complete air is removed from the bottle, almost no sound is heard. Now remove the cork containing the drain pipe from the mouth of the bottle. You will again hear ring of the mobile. Can you tell why does this happen? What is the relation between the ring volume and decreased amount of air? Or air of air. If you remove all the air from the bottle, then you shall hear no sound at all. This proves that the sound needs a medium to travel from one place to another. Propagation. When air has been completely removed from the bottle, we say that there is a vacuum in the bottle. This condition can be for any vessel. When there is a vacuum in a container, no sound is heard, which means sound does not propagate through vacuum. Does sound propagate in liquids? Take a bucket, fill it 3 by 4 with water. Rub two stones together inside the water and place your ear on the surface of the water. Do you hear the sound of rubbing? Do you hear the sound when you remove your ear from the water surface? It is proved through this activity that sound travels through liquid. You will be surprised to know that in this way only whales and dolphins might be communicating underwater. Other aquatic animals also communicate in the similar way. Let us find out if sound can travel through solids also. Activity 8. Take a long metal rod, hold it one end touching to your ear. Ask a friend to gently scratch at the other end of the rod. Do you hear? Do you do you hear the sound of a scratching? Ask your friends also to perform this activity. Ask your friends if they were able to hear the sound of a scratching. Activity 9. Place your ear at the end of a long wooden table kept in a hole of your school. Ask your friend to gently scratch the other end of the table. Can you hear the scratching sound? Ask your friends also to perform this activity. Ask them if they were able to hear a scratching sound. You experienced that sound can travel through wood and metal. This proves that sound can travel through any solid. Let us perform an interesting activity for this. Activity 10. Take two empty tin cans. Punch a hole at the bottom of each can. Pass one end of a string through the hole of one can and tie a knot inside the can. Pass the other end of the string through the hole of the other can and tie a knot inside the can too. Place the open end of the can over your ear and ask your friend to speak into the open end of the other can. Can you say that sound can travel through strings? From the above mentioned activities, you have learned that vibrating objects produce sound. Sound is propagated in air, water, and solid media. Solid media. Sound is carried in all directions in a medium. We hear, we hear sound. We hear sound through our ears. The outer part of the ear is like a funnel. When sound from source enters, it travels through a canal at the end of the canal. There is a thin membrane stretched tightly. The membrane is called the eardrum. Eardrum. To understand the function of eardrum, make an eardrum with a plastic can. Activity 11. Take a plastic can, cut both its ends. Now on one end of this can, stretch a piece of rubber balloon and fasten it with a rubber band. Put some grains of crayons on the stretched balloon. Now ask your friend to speak something from the open end of the can. Observe what happens to the grains of a crayon. Why do the grains jump on the balloon? The eardrum is like a stretched rubber sheet. Eardrum vibrates due to sound vibrations. The eardrum sends the vibrations to the inner ear. There is a fluid and a nerve in the middle ear which is connected to the brain. When the vibrations reach the internal ear, this fluid also starts vibrating. The inner ear converts sound waves into electrical signals and sends them to the brain. The brain interprets these signals as sound. We can hear this sound. Precautions: we must never put a sharp, hard, or pointed object into our ears. It can damage our eyes. A person may become deaf if the eardrum is damaged. He can become hearing impaired. Amplitude, time period, and frequency of vibration. You know that to and fro or back and forth motion of an object along its main position. It's called vibration. This motion is called oscillatory motion. Maximum displacement of an object on either side from main position is called amplitude. Its SI unit is meter m. Time period: the time taken by the vibrating body to take one complete vibration is called time period. Its SI unit is second. Frequency: the number of oscillations per second is called frequency. Its SI unit is hertz. Its symbol is hertz. If an object completes 30 oscillations in 1 second, what will be its frequency? Amplitude and frequency are two important properties of a sound. Can you differentiate sounds on the basis of their amplitude and frequencies? Loudness and pitch. Activity 12. Take a metal tumbler. Stick a metal spoon gently at the edge of the tumbler. Hear the sound produced by the tumbler. Now strike the tumbler hard with the spoon. Is the sound louder when the tumbler is struck hard with the spoon? Now suspend a thermocol ball in such a way that it touches the tumbler. Vibrate the tumbler, the ball gets displaced. How far is the ball displaced? The displacement of the ball is the measure of the amplitude of vibration of the tumbler. Loudness of a sound depends on its amplitude. When the amplitude of the vibration of an object is small, the sound produced is weak. When the amplitude when the amplitude of a vibration is large, the sound produced is sound. In the end, strike the tumbler gently and then with some force. Compare the amplitudes of vibrations in both the cases. Loudness of a sound is proportional to the square of the amplitude of the vibrations which produce the sound. For example, if amplitude becomes 3 times, the loudness increases by 9 times. The loudness of a sound is expressed in a unit called decibel, dB. Above 80 dB, the noise becomes physically painful. The loudness of a sound is determined by its amplitude. When the amplitude of an oscillating object is large, the sound generated is louder when the amplitude is less. The sound produced is feeble. Compare the sound of an adult with that of a baby. Is there any difference? Even if the two sounds are equally loud, they differ in some way. Let us find out how. The frequency determines the pitch or shrillness of a sound. If the frequency of a vibration is higher, we say that the sound has a higher pitch. If the frequency of a vibration is lower, we say that the sound has a lower pitch. Lower pitch, like a drum, oscillates with a low frequency, therefore it produces a low pitch sound. On the other hand, a whistle has a high frequency and hence generates a sound of a higher pitch. A bird produces a high pitched sound while a lion produces a low pitched roar. However, the roar of a lion is very loud, while the sound produced by a bird is quite feeble. Every day you hear the voices of adults and children. Do you observe any difference in their voices? Can you say that the frequency of the voice of an adult is lower than that of a child? Usually, the voice of a woman has a higher frequency than that of a man. Children and women produce a high frequency and a shriller sound as compared to males. Now, 10 audible and inaudible sounds. You know that a vibrating body produces a sound. Can you hear the sound of all vibrating objects? If the frequency of a sound is less than 20 vibrations per second, 20 Hz, then human ear cannot hear it. I sounds of frequencies less than 20 vibrations per second, 20 Hz, cannot be detected by human ear. Such sounds are called inaudible sounds. Similarly, sounds of frequencies higher than about 20,000 vibrations per second, 20 kHz, are also inaudible to human ear. For human ear, the range of audible frequencies is roughly from 20 to 20,000 Hz. So the sound whose frequency is from 20 Hz to 20,000 Hz is called audible sound. Noise and magic. You hear various sounds around you. Is the sound always pleasant, or does it sometimes cause discomfort to you? You find some sounds pleasing and pleasant, while some sounds are unpleasant. Do you like the sounds produced by horns of cars, buses, and trucks? Actually, you find these sounds unpleasant. Such unpleasant sounds are called noise. Do you like the sound produced by harmonium and sitar? Actually, you find these sounds pleasant. Such pleasant sounds are called music. Noise pollution. Presence of excessive unwanted or undriven sound in the environment is called noise pollution. Major causes of noise pollution are sounds of vehicles, machines, loudspeakers, bursting of crackers, etc. What sources in your home cause noise? Transistors, television, and radio played at high volumes. Some kitchen appliances, air conditioners, coolers, etc. cause noise pollution. Harmful effects of noise pollution: presence of excessive noise in the surroundings may cause many health related problems. Noise pollution causes a lack of sleep, hypertension, stress, and many other health diseases. It can also cause hearing impairment. To control noise pollution, we need to control the source of noise. How can we do this? For this, we need to install slashing devices in engines, mechanics, transport vehicles, and home appliances, etc. How can noise pollution be controlled in residential areas? For controlling noise pollution, all noise operations should be conducted away from residential area. Horns of vehicles should be used as less as possible. Noise producing industries should be set up away from residential areas. Television and music systems should be played at low volumes. Trees must be planted along the roads and around the buildings to cut down the noise pollution.